So today I'm going to talk about vegetation and hydrology in forested wetland of Gatineau Park. And I'm Ambika Paudel, a PhD student at Carleton University, and I'm working with two supervisors, Professor Doc King and Professor Maury Richardson. And the one of supervisor is from vegetation and remote sensing, and another supervisor from wetland and hydrology and geochemical, physiochemical. So I'm lucky to have two supervisors from different, different field to work in that project. What's going on here? Oh my God. Oh, okay. So this is outline of my presentation today. So I will start with benefit of wetland and why it is important to study eco-hydrology in wetland. Then I'll talk about my research goal and study area, mainly the wetland that I selected in Gatineau Park. Then I'll go through data collection analysis methodology, and then I'll present result from vegetation hydrology relationship. Then I'll conclude and present some recommendation. And finally, depend on time and interest, maybe I will also talk a little bit about the overall broad implication of my whole PhD project. But the focus of my today talk is on vegetation and hydrology and their relationship. Give me a minute, I'll close my windows. I want to make a little dark, and then I'll turn on light because this light coming directly might be better now. Okay. So why we care about wetland? We all know that wetland are land which are wet for a prolonged period of time to promote aquatic processes, and that indicated by poorly drained soil and prevalence of vegetation adapted for growth in wet environments. And wetland play an important role in hydrological cycle and provide numerous benefits for human society. They harbor a large part of all biodiversity by providing unique habitat for a wide variety of plants and animals, and which also you can quickly visualize from this photograph on this slide. So most of the photograph, in the row, here I took from Gatineau Park. So from basically, I think these are, and the other photo from the lower, the bottom row, I collected some of them from website, and then these two is still from our research site. And what this photograph tell us, this, like you can see frog here, different bird, and then different type of plants, and they grow mainly in wetland habitat. So they need this type of habitat to grow and sustain. And wetland, they often situated at the interface of terrestrial and aquatic system, which you can visualize from this photo on the left side that I took from Gatineau Park. So on the right side here, where you can see trees, this is terrestrial system, and here on left side you can see water ponding there. And that land between this terrestrial and this water, this is the zone, ecotone we call, this is wetland. So usually they're situated in the interface. And what happens if there is a small difference in amount, frequency, or duration of water supply in that area, in that wetland area, that can result in a profound change in the nature of wetland and its plants, animals, and other eco-hydrological and other processes. For example, if we see on right side, on top, this is one of the photo I took from Gatineau Park. What you can see a lot of dead tree in the middle of that pond, and this all on edge, still this is terrestrial area. And this is my expectation that might be, these are conifer tree, and then due to, water log, that's water ponding from long time, they are dying. And if you look at the bottom photo, that is from Louisiana, and there you can see cypress tree drying in wetland, and that is due to dryness. And this gives some example of like how that's impact on vegetation and when these water level decrease or increase. The wetland, they function through strong interaction between ecology and hydrology. In terms of ecology, mainly vegetation interact so closely with hydrologic condition. And hydrologic regime of some wetland are changing with potential effect on distribution and dynamics of vegetation. That is mainly due to changing climate and human intervention. Sorry for that. For example, I took a few photos from the southern side of Gatineau Park. I don't know if I took from somebody's properties, but they're close to road. And what you can see here, you can see that's a conversion of forest to agricultural land, and then this drainage pipe here, they are diverting water, you know, and also we can see that hydro line and road. And these all are human activity. And to understand the influence of hydrologic condition on vegetation community for controlling and restoring ecological processes that will enhance the resilience and resistance of wetland ecosystem to hydrological disturbance. For example, which I saw before, that drought could be, you know, water stress, and a thorough understanding of vegetation community, hydrologic condition, and their relationship is essential to design management priority and conservation program for sustainable management of forests and water resources and conservation of biodiversity, particularly in case of forested wetland, because I'm also talking about sustainable management of forest. So these forested wetland are my study area, focus area. And so what is the forested wetland? It's difficult to find, you know, like even if from definition, people have defined on their way, but there's a general definition is wetland dominated by tree or wooded wetland, we consider forested wetland. And in my research, I consider forested wetland if tree canopy cover is greater than 30%, and which is also defined by Canadian wetland classification system. And you can see on right corner here, this is one of the photo that I took from one of my site. And this is a good example of forested wetland. So the main point is here, why I did eco-hydrology research in forested wetland of Gatineau Park, because the goal of my research was to investigate how vegetation structure and composition explain the hydrologic regime of forested wetland using high resolution remote sensing data and field-based measurement. The park, this Gatineau Park, covered mostly by forested area. It is rich in biodiversity and it has a wide range of habitat and ecosystem, including small patches of forested wetlands. However, this park has been used intensively for recreational purposes, and regional development, pollution, invasive species pose significant threat to native biodiversity and health of its forest and wetland. Enriched in biodiversity, this park, and comprised of abundant water body, which we can see, you know, many lakes, pond, stream, but within a highly variable topography. That's elevation range from 60 to 400 meters from mean sea level. A strong relationship between vegetation and hydrology in the park are expected. However, no attempt has been made to assess such relationship in this park. That's why I did my research there. So the beginning of my research project, I visited over 100 wetland sites in the southern portion of the Gatineau Park to observe their hydrological setting and vegetation characteristics. Many of sites that I visited were identified to be forested wetland, with different type of vegetation composition and structure. And from that, I selected 13 forested wetland and 1 strawberry wetland. And within this 13 wetland, I have established 23 research plots, and that represent full variability in vegetation composition and structure in the southern portion of the Gatineau Park, among the wetland that I visited. And additional criteria also I consider while I selected site, like for example, accessibility of site, close from road, but not like very close. And then another criteria was I didn't want anything very close from road. From that, you know, I wanted like not. I wanted to exclude wetland, like have disturbances or human intervention or impact, and as well as like a beer dam. I avoided if there is any sign of beer dam. I avoided if there is like a hydro line crossing. I also avoided if wetland is a mix, like somewhere marsh, somewhere tree and pond. So there are other criteria as well. And what I did after I selected this wetland, you can see on right side on map, I did boundary survey of each of 14 wetland using highly precise, and then I draw this boundary. This is small blue polygon you can see. And the one interesting features, this wetland, most of the wetland have linear, you know, linearly stressed, linear shape, and they are really vary on size. All the way you can see somewhere here to here. And these are in, you can see here, they are in southern portion. But what I have not included here now, I didn't include the first map where I can show all site that I visited. This is only the site where I focus my eco-hydrological study. And in terms of vegetation measurement, what I did in field, within each research plot, I measure horizontal and vertical attribute of trees and shrubs, using different technique, direct and indirect technique. For example, some of them I put with photographs so that it will be easier and interesting to visualize. For example, I use this synchroclinometer to measure height of tree. It works on trigonometric basics. And then to measure diameter, I use diameter tape. And I use that stick. I label the stick and use stick to estimate height of shrub. And this is the indirect technology is hemispherical photography. And this is hemispherical lens. And I took photo, this upward skyward photo, and photo looks like this. You can see here, these two different photo. It gives at the end, there's a lot of canopy structure related parameter. And I'm more interested to calculate gap fraction, the canopy coverage. So how much area is green and how much area is sky. And then also we can estimate other parameter like leaf area index and so on. And this type of parameter are really useful, you know, for climate and carbon purpose. And in my case, I'm expecting they might have some good relation with hydrology and as well as with the remote sensing data. And for like ground vegetation, for understory, small tree and other fir, fern, grasses, I follow line insect sampling method. So what I did within my research plot, I putting that tape, I established a transect, 20 meter by 10 meter transect, and they are passing through the middle of the plot. And I did like in every 2 meter interval using some certain size of stick, and I counted all species, their number, and I also measure height of, you know, like one height for one species, one individual from one species, but which is the tallest one. So some sort of analysis I did too, and that is really helpful to estimate understory vegetation cover, diversity and height of understory vegetation. And in terms of water level, soil and physiochemical data, what I did, I installed numerous well and piezometer within each research plot. And this this well, inside well, I have I kept automatic water level monitoring logger, data logger. And that's record water level and I also did weeks here inside, and there is a standing water outside. I also did, we install well, and these are my research assistant. And what we did, we also collected water sample from well and piezometer, and then I in lab later I derived a lot of parameter like cation, anion, so plant nutrient, pH, soil specific conductivity, DOC, isotopes, a lot of other chemical, parameters. And this is the second objective of my research, which, and I also did soil sampling, and I calculated soil organic matter content. And in terms of remote sensing, I am using high resolution. I flew drone in Gatineau Park last year in few sites, and also LiDAR drone, high resolution remote sensing data I'm working with. And then with all data, currently I'm doing a data analysis, and I'm almost ready to submit one publication. And I'm using statistical analysis regression, and the little advanced one is multivariate gradient analysis technique, and I'm doing this analysis usually in our STAR software. So today what I'm going to do, rest of the thing I'll keep for the next time if I get the opportunity to present again. So today I'll focus, I'll present some interesting result from vegetation-hydrology relationship. So what you can see here, only from that 14 wetland, I found a total of 75 plant species I recorded there. And there you can see on this bar graph here on right side, and there see this 39 were for these flowering herbs, and then followed by tree. You can see that of course they are forested wetlands, tree, and then other, and then straw and grass and so on, you can see here. And the most important thing in wetland, what this data suggests to us, forested wetland could provide critical habitat for several type of plant and ground vegetation, bryophyte, shrub, herb, but with the richest diversity we can see for flowering herbs, and which you can see here. And the second important thing, in this wetland, major of species, I think most 65% of species that I recorded were wetland species, and these wetland species usually we in moist side of the upland environment, forested environments. And what you can see here, that the indicator species almost 50%, that's 45%, almost half of the species were indicator species. And I already talked this, we found like most of these species were flowering herb, and I thought it will be nice for you guys to see like which were these species there. And then I pick up photo of common flowering herb I found within forested wetland that I study, and which you can see with the nice flower here. And so among these species, this one, Canada Mayflower, then canker root and white ester, they can grow in both environment, usually in moist soil, and then also dwarf raspberry. But all this rest of these species, now this northern bogleweed, marigold, touch-me-not, and bird marigold, they need wet habitat to grow. They are wetland indicator species. But bunchberry grow in moist area, whether in wetland or in the moist side of the other forested habitat. And the second really cool thing what I found in understory on ground vegetation, if you go inside the wet diversity here, it really rich in plant species diversity. Within a small patch, you can see, for example, this is maple regenerating, this is balsam regenerating here, and you can see this herbaceous, different herbaceous plants. And if you look, for example, here, these are tree, you can see cattle there, and this flowering plant, grasses, and you also, visualize, other like grass, plant growing together. And there are a lot of this type of patches within forested wetland. And so my main component is tree, because my main research goal is to link with the remote sensing data. And so I focus study on tree later after I characterize everything. And in terms of tree, these are the, among the 12 tree species I found, 7 species were wetland species, and other species were upland species. And upland species because they are, these wetlands are surrounded by upland forest. So it's not surprising to have few upland species in wetland. And I didn't mention these upland species here, but among the wetland species, what you can see that yellow birch was more, and red maple was these two are the most common species I found in most of the site, even 90%, while black ash and hemlock, although they were not abundant, although they were not commonly found everywhere across the site, they were abundant where black ash is a water loving, or let's say it's a wetland indicator species that grow well in wet environment. So in wet side, I found abundant black ash, and in a drier side, I didn't find any black ash. So, and the similar work for, other species. But it's surprisingly for yellow birch, even it found in almost everywhere, but it was not abundant, in many sites, it was just abundant in one side. And this abundant I define using 50% threshold. So I counted all 3 inside the plot, and if one species have more than 50%, and then I consider that species is like colonized, is abundant there. And what this result tells us, the dominance and dispersion. This dominance means like having a lot of species, and dispersion, how they are, how is their habitat preference, whether they are clustered in one area or they are, they find in, what is called that, they disperse, or we can find in different place. This pattern is not uniform, it's differ across site and across species. And after I characterize all this vegetation and their number of tree density, their height, diameter, and then their health condition, different parameter, I had about 70 vegetation variable I measure and derive, and I calculated for each plot. And based on that, I did regression analysis. I look relation between each of vegetation and each of hydrology variable. And then what I did, I grouped them for vegetation based on standard wetland classification of our Canadian wetland classification system. So according to Canadian wetland classification system, forested wetland are classified in 3 major groups. That's hardwood wetland, mixed-wood, and coniferous wetland. And within this hardwood, mixed-wood, coniferous, we can subdivide different vegetation community based on their, dominant species, which I did here. For example, within hardwood wetland, based on what is the dominant species, like this is ash-dominated wetland here, greater than 60% ash. This is red maple dominated, and this is the mix. And if you look on right side, you can see these all photo I took on last week of May. 2019, almost same time, so that you can compare easily. And this is the photo from ash dominated side, where you can see high number of trees and some flowering plant. These are marigold at the bottom, and you can see water because they are wetter side. And if you go in the middle, they are relatively drier side, but with larger tree, and they're form in understory, and they're just sprouting. So you don't see flowering plant anything here. And if you look at the bottom side, and this is mixed hardwood, so you can see yellow birch and other and red maple, ash as well, but different type of hardwood tree species, not like one species abundant there. And on ground, you can see a lot of grasses, sages, and ground vegetation is different than these two. So, and this information I also put here in terms of height. These are bigger tree, you can see height here. And in terms of another information is health of tree. I measure, I categorize poor, very poor, fair, good, very good, dead, live. And then in this side where we have ash tree, we have a lot of unhealthy tree, means their tree already infected by EAB, emerald ash borer. I'll talk about this later. And compared to other two sides. And if you look in next slide here, this is another type of forested wetland group, which we can clearly view on this photo. This is the shrub dominated site, and this is tree dominated with no shrub, and understory also different. And you can see size is not much different, but the understory and then the number of tree, the density. Here we have a lot of tree, here we have a lot of shrub. And these also, these two different, distinct group within one wetland type. And similarly, when we look within coniferous wetland site, also I found three distinct groups. First two distinct groups. So one is dominated by hemlock, eastern hemlock, abundant eastern hemlock, you can see with a lot of, course, density high. And if you look bottom photo, see it's a very big size of tree, and there are spruce and hemlock, and there were other one plot, different than even these two, with some yellow birds. And also you can see the difference in the tree number, but there is no difference in health, and slightly difference, of course, in size. And the main difference in number of tree, density, and the understory. So in terms of hydrology, that all was about vegetation. So first I characterize all vegetation. And then when what I mentioned before, I put logger inside well, and that record water level in every 15 minutes. And I put everything, and I plotted here over I started recording from last week of May, and I took logger in last week of October. So if you look this graph, you can see a very similar pattern overall, general pattern. At the beginning, they have water, let's say, and here is more gentle in hardwood. And if you look in the first week of August, you can see sharp drawdown, is the water table going down all the way here, and in this similar pattern everywhere you can see. And then during the dry period, when water level was below ground, you can see like pretty stable here in hardwood, but more fluctuating here and here. And it's gentle fluctuating. October, again, they are coming back. Okay, so wet, dry, wet. This is the seasonal cycle of water level. This is dry season. These are wet season. But if you look overall, what you can see, we can see noticeable difference within hardwood. Here, this is the one, and these two side here and this side here. And one clue I mentioned you before when I was talking about vegetation, I talk about black ash dominated wetland, which have a lot of tree, and we can see water there, and that's the wetland indicator species. So these which are close to ground, these are water table graph from this site, wetter site. And these which are just below, these are graph from the other, either red maple dominated or mixed hardwood site, which are relatively drier, and they have more fluctuation, like standard deviation high all the way from here to here, but they are gentle fluctuation when water is dry compared to the other side here. And this shrubby side, there are two shrubby side. I took one of shrubby side. There are very few trees, but just to see as an end what happened, how much different we can see between strobicide and tree side. That's why I excluded one strobicide with the one with the green. I didn't have a lot of tree there, so I cannot consider it as a forested wetland. I excluded from the forward analysis. And excluding that side, keeping only my 30 forested wetland, what I found, the average growing season water level in forested wetland was slightly below the ground. And minimum is close to 1 meter from ground level. So water can go all the way down up to 1 meter in some site. But when in spring, after snow melts, or in fall after heavy rain, it can come up to 21 centimeter up, above from the ground. And if I compare between site, across site, the average standard deviation, range are highly variable. You can see the average water level was 3.6 centimeter above ground in one side to 72.6 centimeter below ground in other side. In the driest side, its average was below ground. And relatively, what we can see I also measure standard deviation. So highest water level with relatively more stable position I found in conifer site, while other hardwood species, means excluding those ash tree dominated site, had lowest water level and more fluctuating water level. And I also measure, we call hydro periods, as the duration of wet period, means how much of the time, like when I did all measurement put together, then I grouped the measurement when water level was above ground and when was below ground. And then I calculate the time in percentage. And what I found, that's range of water when water is above ground is 25 to 75% of growing season. And the shortest rain was in that hardwood dominated site, while the longest range I found in conifer dominated site. And so these findings from that vegetation separately and that hydrology separately tells us qualitatively there are differences in water table depth, variability, hydro period among wetland site in relation to vegetation characteristics. So next step of my research is to test their relationship statistically, whether that relation is statistically meaningful or not, whether we can predict vegetation structure and composition using hydrological parameters. For that I already mentioned regression analysis first between each pair of vegetation and hydrology, which I'm not going to present today because this is too much. I have number of table and results. But after that regression, what I did, I sorted out the variable. I started regression with almost 70 variable, and then I come with the 17 variable, 17 of vegetation, which you can see this variable here on this table. And putting all these 70 variable and all, I have 15 hydrological variables. So putting all vegetation, all hydrology, that vegetation I selected based on like how their representation, like including stocks or composition, diversity, cover everything, and based on literature review and consulting with my supervisor and other study. And these all vegetation, these all hydrology variable, I can put together and run a model. If I use a multivariate gradient analysis approach, I use the redundancy analysis, one statistical method, which is really good if we have a strong relation between each pair of two set of variable, then it makes sense to put all them together and see how they distribute, how they interact with each other. And also the cool thing with this method, what we can see, we can plot site, this research site. Look, this research site also we can plot on graph along with this hydrology is my X parameter. I want to predict vegetation based on hydrology. And then this Y or response variable. So it might look complex for those of us which are looking first time, but this is not really as complex as we think. This graph is cool. What it tells, This is x-axis here. This is y-axis simply. I put two axes. And on x-axis, this blue, this arrowhead, the arrow tells which variable is how strong. There's a strength of variable, and the angle between variable tell their correlation. So closer the arrow means stronger the correlation. If they are on opposite side, they have negative correlation. And what it tells here, this is medium water level. So let's say average water level, medium water level during growing season of wetland. And this is the standard deviation during the dry period. And on x-axis, when water level is high in wetland, this variable tells the regeneration, tree density, diversity, proportion of wetland species will be higher. So this variable will increase with increasing water level, and opposite side, whatever here, they will decrease with increasing water level. And similarly, if we look from x, y side, I have proportion of hardwood, health of tree, and size of tree. And when the standard deviation, when the water level is highly variable, this is standard deviation increase, highly variable. This way, the deviation is increased means when water level is variable, we'll have a lot of hardwood tree on this side. And when water level is opposite, is more stable, these plot are my conifer dominated plot. Okay, so what I can tell you, these 5 plot from here, these 3 and these 2, all are conifer dominated plot. They stand out on the opposite side where water level is high and stable. And these hardwood stand out here when water level is low and highly variable. And but these are also hardwood, but they are here when water level is high, but not as stable as this side. And whatever I have like straw or mix of conifer and hardwood, they are close to center of the plot. So what it tells in summary, the conifer dominated site, they are mainly prevalent in the wet area here and as well as with stable water table, while strawberry or mixed site are present in intermediate condition, not very dry, not very high water level. However, hardwood dominated site exists in a relatively longer gradient. We call that gradient. So all the way these are hardwood and these are hardwood. These all below that graph are hardwood. And this corner, those are growing in dry habitat with highly stable, unstable water level, low water level are clustered on the left side of the graph. And those are, those have a lot of indicator species, smaller tree size, unhealthy tree, but have high water level. They are on the right side. Okay, so it gives us an idea of how our sites are clustered each other and which variable help to discriminate this site along the gradient and cluster. So among the 14, 15 variable I started in modeling, I ended with the best model with 3 hydrologic variables which are blue. And these are the best variable to predict vegetation distribution, vegetation structure, composition of forested wetland in my study area. And they also can nicely separate, the discriminate site into different cluster and different group. So I'm done. What's the time here? And I'm done my result part. I have a lot of result. I'm going to submit papers soon based on this result, but I try to summarize. I don't know how much, I could make you clear on that, the complex plot. But one thing I really want to emphasize here, I hope there might be people and research person from NCC as well, maybe interested, or these are the people can apply this finding if they want. What I found in my research site, you can see clearly in those black ash dominated site, there is a problem of EAB, that's an everland ash borer, which is invasive borer that attack that ash tree, and this is really terrible in North America. This is the problem also in Toronto urban area as well, not only in natural forested side, wherever we have ash. And I found a lot of ash tree infected by that borer, and you can see here when I went in spring, I can see nice flowering plant and this ash tree, and later when I visited in summer, you can see the same area is changing, their bark coming out, the borer already attracted. And when I went the same area in winter, there was, you can see some snow here, and I zoomed the most impacted, the biggest tree, and you can see this mark of that borer. And the one is from another my research site was terrible. I saw a lot of this type of tree. It's already dead, and you can see this mark. See the way how the borer attacked. And another side also, similar trend I found from this side, like when I have understory with fawn or understory with grass or under whatever is in understory. If we have ash tree in overstory, they are dying there. And based on my literature review in North America, some people mention that when there are ash in wetland, even this is higher chance to get infected by borer. And there are still people are working on that. And what I found in Gatineau Park, when I go to the wetland, I found most of the ash tree are infected with the borer, and just nearby upland spaces where I can see few ash tree on moist side, I didn't find, often they are infected with borer. So I also agree with their, the initial finding that might be something, related to their habitat and tree growing in wet. But still this is not part of my major part of my research. I'm just interested on this, and then I thought it's good forum to share here about this finding. And the impact, what gonna happen, in future if you stay like this, this EAB, this ash borer induced mortality will likely create significant change in hydrologic condition. The one thing, they reduce that leaf area, means they reduce transpiration when there is a high water level. And also what happened, reduce overstory transpiration, and then they don't have like if there are a lot of dead tree, and they control, that's the evaporation coming from the understory and soil, providing shade. And in the long run, when this water level increasing and tree dying, and there will be a higher chance of converting this forested wetland to herbaceous, cover wetland like marsh, which I also found, some site in Gatineau Park. See, you can see already dead ash tree and lot of grasses and cactus you can see in understory. I just visited this site once, so I don't know the change, but I'm expecting something might go slowly, in long run. So based on all this finding, I'm now on my conclusion. So what this study demonstrated that sample of temperate forested wetland that I study can support all type of forested wetland that I mentioned in that we mentioned in Canadian classification system. These are all hardwood dominated, mixed wood, conifer, and even within hardwood I found mineral and organic. These organic are ash dominated, so organic soil. And with the diversity in vegetation, structure, composition, and as well as what I just presented, water table position, variability, hydro period also vary across site and within and between wetland type. And this variation of vegetation composition structure among site is highly dependent on water table dynamics, which I also show you from that from that graph. And on the left side, I didn't talk about that. There was a table, it shows the correlation, and there is a really high correlation among the hydrology variable, hydrometric variable, and vegetation variable. It tells vegetation is highly dependent on hydrologic condition. And understory of vegetation, I already show you a lot of photograph there. We can see is really, really rich in diversity. And I also have few photo I didn't include here. If I take photo, if I look wetland and upland and the transition, you can see very nice transition, lot of species in understory, very high diversity in wetland, and slowly decreasing in the transition, and then you don't find like only few regeneration and some flowering plant in uplands. You can see that's nice transition in Gatineau Park. And this EAV infestation in ash-dominated water site is more likely to decrease forested wetland in near future in Gatineau Park and shift to only, without trees, just grassy wetland. And problem is not only in this side. Another problem I notice in relatively drier, moisture side, there are very few trees. Very few tree, but very large tree, and they don't have regeneration. Very few regeneration in understory and almost open understory, and they have longer dry period, and their water level is below. And in such side, if there is no enough water in summer, and this big tree do a lot of evapotranspiration, and then slowly wetland indicator species, slowly they may disappear there, because if there is no water, they cannot stay, they cannot survive theirs. And if extreme condition happen, is every summer is climate changing, getting dry and dry. In extreme dry condition, a such site can experience water level way down. We already found like close to 1 meters. And if in such dry condition, if there is a like drought stage, have to tolerate by plant. And this type of site and wetland might be slowly, gradually replaced by upland species, which can grow in drier environment, and then consequently that also lead reduction of forested wetland in the park. Thus, appropriate management strategy to control that EAV infestation, as well as to maintain like vegetation in the drier wetland site should be adapted in the park to maintain and conserve such unique habitat of biological diversity. Thank you so much for your attention.